So to say, now we will be talking about the laws that govern the rate of decay of radioactive substances. And we understand now that there happen to have some nucleuses which are unstable, and there are some basic reasons for these nuclei to be unstable, like their binding energy per nucleon is less, or the electrostatic repulsion between the protons is more in certain cases. Now, what are the laws that govern this radioactive decay? We would like to have the statements of these laws. And, and if I assume that I have a radioactive substance, so radioactive substance, what can I say about it is the rate of disintegration of radioactive substance. Uh, that is the number of nuclei that decay per unit time at an instant is directly proportional to the number of nuclei in the radioactive substance at that time. So that's how the statement goes here, that the rate of disintegration of this radioactive material is at a particular instant is directly proportional to its number of nuclei that are present in this radioactive substance. Right now, now what could be the possible laws that govern such things? The very first thing I would like to say is that this radioactive disintegration, or what you call as radioactive distinction. What is it? It is a spontaneous process. Okay, it is a spontaneous process, and it is not affected by. It's not affected by external conditions like temperature. It's not affected by pressure, right? So this could be first important consequence of these radioactive decays, that there is no impact of temperature or pressure on the process of decay of these radioactive nucleuses. Now, the next important thing is that at a given time, a nucleus, if we have a nucleus, will emit one particle. So one particle at one given time, and it will either emit an alpha particle or it will emit beta particle only. I mean, both alpha and beta particles are not emitted simultaneously. So alpha and beta, they are emitted separately, and gamma ray emission follows the emission of alpha or beta particle. You can have the gamma ray particle being emitted by this radioactive substance once alpha or a beta particle is emitted. The next important thing is that when a radioactive element decays, uh, when a radioactive element decays by emitting an alpha particle, so what happens in this case? The position of the daughter nuclei or the daughter element is down by two places in the periodic table. And that's quite clear about the alpha decay. And similarly, when we have when a radioactive element decays by emitting a beta particle, what happens in this case? The position of the daughter element is raised by the place in the periodic table, right? So in case of beta decay, what's happening is that you have the impact on the atomic number of the nucleus, and by having alpha decay, what we have said is that the position of the daughter element is down by two places in the periodic table. The next important thing is that when we have a radioactive element and that emits a gamma ray, now its position will remain same. The gamma ray particle, it's not going to change the position of this element in the periodic table, and the radioactive element in the excited state goes to the ground state. While coming to the ground state, it emits a particle, gamma ray particle. So the set of rules that I have talked about here, they form the basic statements of the laws of radioactive decay.